Okay, so today's session is building scalable web applications with Spring and GemFire. So we're going to do a very short GemFire overview. This is going to be very brief, quick little demo. We're going to show sort of in running order some of the features we'll be looking at, and then we're going to develop some code. So the main thing we're going to develop today is we're going to create a model, a repository, and a client, and we're going to look at configuring the grid, the cluster, the GemFire cluster, to be able to deal with that. And then we'll take a look at some more advanced code, such as functions that can run on the server, continuous query, and some other features. So first off, what is GemFire? So this is a distributed system. It uses JVM, so it uses heap memory. It does have optional disk storage, so should a system be turned off for some reason, it can recover its state. It's key value store, so it stores objects or JSON. It has a query language called OQL, which we'll see today, parallel function execution as well. It's a shared nothing architecture, so each member of the cluster is independent of other members and can operate and do its data operations on its own. It also supports a multi-site distribution. So what can happen is clusters can actually share data across a WAN. So you end up with sort of a global data fabric. So, this is just sort of touching the surface of the functionality. We're going to just keep it higher level today because we want to actually, look at building an app. So people use it because it's scalable. We're going to look at partition data today. So this allows for scalability. So we'll see that in practice once we build out our sample. It's a lightweight process, so easy to spin up and get going. It's got high read and write throughput. So all the sort of replication and transfer of data to keep the grid consistent happens asynchronously behind the scenes. There's multiple copies of data across the partitions. You can configure as many as you like, and this allows a single primary copy to be written to, and then all the secondary copies to be read from. We'll talk about something called single hop access shortly. There's a rich event framework, so we'll see GemFire can actually push information out to clients connected to it, which is a very powerful feature. And then, of course, group membership. So, it can maintain members and data across a cluster and, scale out very nicely. So the focus of today is Spring and GemFire have a great integration. So there's a project we'll be looking at a lot today called Spring Data GemFire, which allows us to use some very familiar Spring programming models against GemFire. There's Spring Boot, which gives us a great sort of quick start to a project that's going to use GemFire. And we'll talk briefly about Spring XD today and how it works with GemFire. So this is a recent article from Forbes, just who's using it. So you can check out the article. The Indian Railway is selling tickets. This is a little snippet from the article. This just sort of highlights why people would want to use Gem. So 17 million records in memory, 3 terabytes of operational data, 48 terabytes archived. So you can sort of have data sweeping and load it in as required. 40,000 transactions per second, 4,000 concurrent client connections. So, this is for a low latency, high volume system that you need to scale up and scale down. So you can get GemFire from network.pivotal.io. You can just download it. The current version is 8. Obviously, when we start coding, we'll be using Maven to get it. But if you just want to download it and take a look, this is what you'll see. So it's just some folders, the critical one being the lib folder, which contains all the dependencies, as well as the GemFire jar, which obviously is the key piece of this. So GemFire, as you can see, it's just a Java package. You're just starting a process, and it's a Java process, passing it some configurations, and that's how it works. And everything we need to run it is in this folder. Now, I've highlighted in the bin folder something called gfish. So gfish is a way to work with GemFire. There's multiple ways. It has an API. It has a few tools, but we're going to be fairly focused today, so I'll be using gfish. This is GemFire shell. So it gives you an interactive shell for starting, stopping, and managing the cluster and all the members. So you can see here there's autocompletes. I've just done a tab, and I've got a list of all the functions. So I can start locators, start servers, etc. So GemFire simplified each server process. So we've got two types of members in the cluster, locators and servers. This is looking at a server. So we've got our JVM. There is an instance of a cache. Inside of the cache, there's a collection of regions. Regions are where the data goes. Regions are basically an implementation of java.util.hashmap. So it's key value, like we said. And then there can be logic that's deployed to the grid that can operate on the region within each cluster in parallel. So GemFire terminology, as I said, there's a single cache across the cluster. The region is the implementation of hashmap. We have two types of regions, partitioned and replicated. So partitioned, if I have 6 members and I put data in, it basically gets, each put gets spread across. You can have your own sort of partitioning algorithm, or GemFire will do one on its own to make sure, or try and make sure things are evenly distributed. And then, of course, you can have your redundant copies. So, over the 6, you'd probably want to have your primary and 2 secondary. Replicated regions, every time I put something in, it's automatically copied to every member that has that replicated region defined. We're not really going to talk much about those today. There's more power with partitioned regions. Lots of settings and configurations for regions, expiration, read-throughs, write-throughs, just persistence, etc. Fortunately, we won't be able to get into all of this. So my handy little animations, unfortunately, aren't viewable with this flat slide, but there's a lot of ways to deploy GemFire. This is what we're going to play with today. So we've got a cluster, 6 machines that are running GemFire processes. So 2 are locator processes, 4 are cluster server processes. And over here are clients. So every application has a GemFire client inside of it. And that client is a cache itself with regions. And we'll see when we configure what that looks like. Yeah, there's communication over TCP/IP. Clients can communicate directly with the servers. And we're in a Java Spring world here, but these actually can be C# or C++ clients as well. Okay, so what we're going to do is just briefly take a look at small GemFire demonstration. I want to demonstrate an application for you, and we're going to go back and look at its sort of underpinnings from a code point of view after we've sort of cut a little code ourselves. So this is a VM environment. I've got a locator process and 2 server processes actually running inside of this VM. This is something I just use, for quick sort of demonstrations and playing around. Get into this in a second. Just going to let the grid start. Just close this down. So this is just going to give us a quick view of some of the features we'll be talking about today, just so you can see a running GemFire application. So the first process we're starting is a locator. It's listening on a port and IP. It's the senior member. It's also the JMX manager, so it's a management port as well as the senior member in terms of group membership. So you see these folders have been created with the PIDs, artifacts such as logging and statistics files that our support team would use should they have to troubleshoot. So if we open up a browser session here, we've got Nagios. What I wanted to look for is Pulse. So the first locator to start up becomes, as I said, a JMX manager, and it hosts a web application called Pulse. This is just something you can log on to, and what it does is it shows you your grid. So it shows you your memory, it shows you the regions, the number of clients. So you'll see the number just jumped up to 3. If we go here to data, you can see we have a number of regions. You'll see this is changing and shifting around, and that's because data is being sent to the grid right now. So what's happening is some of the data being pumped into the grid is going into replicated, some is going into partitioning, and the system is basically distributing and allocating things. So, as you add or remove members, you don't have to worry about sharding or anything like that. If you add a member, the grid can rebalance itself and redistribute things. If we take a look at a more straightforward view, we can see we've got a couple replicated and partitioned regions with a number of entries. So this is a grid that contains, some configuration, which we'll be building today, as well as some definitions. So that started up. So I'm going to start the demo. You'll notice this demo is a Spring Boot application. This is how we'll build our client today as well. It's a really convenient, nice way to get going. So this application, its client connects to the grid I just started up. And let's see how it looks. So it's started up. So this is a Spring Boot app. It uses Timeleaf for the UI. These totals are coming from the grid. They're calculated with a function. This is pulling the grid every 3 seconds to get a value. You can see if we go into, let's say, orders and place an order, due to GemFire's low latency, I can do a text match on millions of records and get back a result very quickly. So we can place an order. So it can be a system of record as well as sort of an ingest and compute solution. So I don't want to spend too much time here. Now, where it gets interesting is I have another Spring Boot app that I'm going to spin up. It's going to connect to the grid and start flooding the grid with data. So it batches up transactions, throws them at the grid, every 5 seconds. It puts 25. So you'll see this has started putting transactions. Now, you'll see a few things are happening. So our totals are updating. These totals are updating as we pull, and these messages start to come in. So this application has registered a query with GemFire and said if any product reaches a quantity of 22 or less, send that object to my client cache. And this gives you an opportunity to do something about data as it's changing. So in this case, I can place an order before this stock becomes, out of stock, this particular item, but it gives you a lot of potential to react to changes in data in this sort of global data fabric the second they happen. So every client connecting would register this, and GemFire would update all those clients. So this sort of just gives you a front-end view of the types of things you're going to build. What we're going to build today is going to be a little less fancy than this, but that's okay. By the way, you can monitor with Nagios as well. I've got here, where did I put it? So here's my GemFire grid. I only have one locator, so this is marked as critical. You should have at least two. So that just gives you kind of an overview. Let's dig in and start making some things. So I'm just going to shut all this down. What we'll be working with today. So here's the flow we're going to go through today. We're going to configure a cluster. We're going to code a model. We're going to code a repository. We're going to make a test case that tests the repository's functionality. We're going to code a client application that uses those repos and actually puts some of the models into the grid. And then we're going to review a function. I would love to run through the function and also a few other things, but this is a very short time frame for the session. So this is the environment we'll be working with today. So on the desk just across from me, I have 4 gigabit bricks with Ubuntu server, 8 gigs of RAM, Oracle JDK 7, which is the supported JDK. Our next release will support 8, GemFire 8, a router. They're all communicating on a switch. My development and client is my Mac laptop, and I'm using STS, my editor of choice, JDK 8, and I'm using something called Ansible, which you'll see. I'm using that to basically manage my grid from a distribution point of view, and you'll see that running in a second. So let's talk about configuring the server. So let's just head over here to Ansible. Let's kill a few of these. So let's do an Ansible ping all. Actually, we'll ping cluster. So Ansible just allows you to group IPs under a name and then issue commands, and it broadcasts those commands out. And I just did this session previously, so you'll see there's some commands left over. So I have essentially 6 computers, and they're all reporting back to me. They have nothing but the operating system, the GemFire binary, Java, and SSH, obviously, for Ansible to work. So I've broken them up into 2 machines run 2 machines run locators, and 4 machines run server processes. And what I've done is I've created scripts that are on all machines. So I could actually technically make any machine a locator or a server, but I've made a decision to sort of split up my resources. So in terms of configuration, this is what it looks like. So gfish is something I can run on the host machine, and it can create a server process and create a cache. Now, I can have it bootstrap Spring. In bootstrapping Spring, it'll load up a context. And then within the Spring context, I can define regions, server-side logic, and those will get added to the cache. Now, in a release coming soon, whoops, keep forgetting. In a release coming soon, what you'll be able to do is actually have gfish start with a Spring context directly. So rather than GemFire creating the context and then GemFire booting up Spring or bootstrapping Spring, Spring will start up and it'll, create the cache and then all of the components. But for now, today, this is the process we're going to do. So we're going to create a GemFire cache.xml. It's going to reference our Spring config, and then we're going to configure everything in the application context. Now, I know a lot of you are spoiled, especially out there with boot and all these annotations and things like we felt like we saw the end of XML perhaps a while back. So why not use annotations? And Spring Data GemFire does provide some annotation support, but it actually doesn't have full support for all GemFire options. And also, the editor provides a lot of assistance. And as you'll see, while we're configuring these things, you really need some assistance because GemFire has so many configuration options. So it actually, as painful as it might be to some, it's easier to work with the XML. Okay, so let's configure the server and deploy the code. Here we go. So what I'm going to do is create a Spring Boot application. So I'm going to use Spring Boot and straight up Maven today. Now, one thing I do want to do, I do have the server already running from the previous session. So what I'm going to do is issue a command to all the servers through Ansible to shut down, just so we can get back to kind of an initial starting state. So on every server, I have a set of scripts, shell scripts. Those shell scripts call gfish and do things like start the locator, stop the locator, and what have you. So I'm pushing this out to all the servers, and they're calling this command to gfish. Gfish is managing the GemFire process in that machine. So in this case, it's shutting them down. And just so we know what we're dealing with, here is, so the locator that we're working with is 192.68752. We've got 2 locators running. So I have 2 locator processes here. So we'll keep an eye on this as we go forward. So let's start by building out our project. So in the previous session I did this, I ran out of time quite badly. So I will be doing a little bit of copy-paste. Hope you guys don't mind, just to speed things along, because you probably don't want to watch me create XML all day. All right, so let's go with a Spring Starter project. So this will be io.pivotal.gemfire.webinar, and we'll call this figs, except I meant to type that in my package or my group. Okay, so we'll call this GemFire configs. So all we're going to select here is GemFire. So Spring Boot does a great job of bringing everything in we need. That's good. Okay. Okay. So the reason I bought Boot is it brings in everything we need in the class path for me to configure this without really any hassle. You'll notice it did bring in GemFire 702. The next version of Spring Data will result in an update to GemFire 8. But for the configuration we're doing, this is going to be just fine. So we're going to create our XML here. So the first XML we have to create is cache.xml. This is the GemFire cache. Just to save time on typing, I'm actually just going to copy and paste this from another directory. Okay. So a couple of things going on here. So this is cache.xml. Gfish will take this and use this to start a GemFire process on the machine. So in this case, it's going to be a server process. Locators don't store data, so the locator process starts without this configuration file, but the server starts with this. You'll notice there's a PDX serializer configured, and this is the package we're going to use when we create our model. I'll put this in now and not build up to it just in the interest of time, but GemFire stores its data in a serialized fashion, and this allows me to define POJOs without having to put any serialization or implement anything special. So we have this here, clients and the server have this. And then we have an initializer, and our initializer we're going to create, or we're going to load up this Spring cache, and that cache will configure the rest of the grid. So let's create that now. So we're going to go and create a Spring configuration file called Spring cache.xml. So luckily we have all the namespaces we need here. So all we really need in this case is Spring Data GemFire. But as you'll see, as we build other things, you know, Boot's great for bringing everything we need. Now, I do have an older version of Spring Data GemFire that released before this one on the server. So I'm just going to remove those version numbers. Okay, so let's configure the server. Now, here's where the XML gets really interesting. As I type in GFE, I get the completes. I can do cache. And if I do a control space, I have all the settings. And GemFire has a huge amount of settings. It really does a lot of things. We won't have time to explore all of them, or even half of them, but it's a very robust tool. So this is the first thing, a cache. The next thing, this is a server process. So we need to define a cache server process. So just in the interest of time, I am going to do a copy paste here. I think you guys get the picture that, you know, the IDE does help. So let's add a few more elements. Okay. So we've added a cache server. It's listening on port 0, meaning it will take whatever available port on the server. It will give the senior member of the cluster, which in our case is one of the locators, its details. So the information that it's storing and its IP and port. When clients connect to this grid, they will create a direct connection, if single hop is enabled, directly to the server that has the data they need. So they don't have to go through a secondary piece. So here's our server. We have two regions. They're partitioned, so they'll be distributed across the cluster. If I wanted to add redundant copies, I could do so here. One of the settings in here gives us our copies. Forget which one it is. That's okay. Now you'll notice we have it co-located with customer. So the order you'll see once we create the domain object, it has an ID that links it to the customer object. So when the two are being distributed across the cluster, we want customers and their related order objects to end up in the same node. And this makes things a lot more efficient from a function and a query execution because you can do joins in the query language. We will talk, there's other strategies for modeling objects, but we'll get into that when we talk about object modeling. The last thing we need, it's going to be another quick copy-paste job, is a GemFire.properties. So I'm just going to copy this in. So the GemFire.properties gives us basically grid level configuration. And there is a host of settings here. So just to give you an idea, lots of different behavior you can tweak, security, auto reconnects, all sorts of things. So we don't have time to explain that. I'm just setting logging, turning off multicast, and I'm enabling statistics, which is handy for troubleshooting. Okay, so that's it. These three files are all that I need. So I have an Ansible command that will basically copy up all my configurations. So let me just find that command. Okay. So this will upload, so I have the identical directory structure in all the machines. So that's done. If we SSH into one of them, let's say GemFire 4, which is a server process. Conf is where these are going. Lib is where we'll put functions and any kind of Java code we need the grid to exercise on server-side logic. And scripts is what Ansible is calling. So I've written shell scripts that call gfish processes. So essentially, Ansible keeps everything synced up, and then I just decide what to execute. So speaking of executing, let's start up the servers. So right now we have two locators running. Let's add the servers to the mix. So Ansible, I'm going to tell it on each server machine, run my start server, which is going to do the gfish command to start up a server process, adding all this stuff to the cat class path and that config, and use the cache.xml, which is the file that we've created for the server definition. So what we can do is just watch pulse. So right now we can see our total heap is jumping up because members are increasing, and our region count is 2. Because if you remember, we had 2 regions, order and product, or customer. So our heap count continues to increase. So even though there's 8 gigs per machine, I didn't allocate all of that. So with all 6, I think we're going to hit around 10 gigs, if I remember, in the last session. So 4 members waiting, there's 5, and we should get 6 here pretty soon. So while we're waiting for that, here's our regions. So customer, order, both partitioned, no entry count. Our heap is up just over 10, so we've got our 6 processes. So we've just configured our server to take two regions and distribute them, one called customer and one called order, and we're going to co-locate order and customer. So the next step is let's actually code those domain objects and look at putting them in the grid. So in this particular case, I could do another Spring Boot app, but just to show you don't have to use Boot, I'm going to use just regular Maven. Now, because we already specified our PDX serializer, and this is the package that's going to get serialized, I want to make sure everything matches up. I'll call this GS. Okay, so a simple Maven project. I am going to add a couple things to the POM file. I'm just going to copy and paste those, and then we'll review what those are. So let me just get my POM file. So I've added a repository. Oh, didn't add it. So those are just the dependencies, and I've got some references there that will need properties. Here we go. So I've added a repository, which is a Spring release repository. We're using a couple of projects. Some of these we don't need, like MySQL. This is from a previous project. So we're bringing in GemFire. I could bring in 8, but I'm going to stick with 7 to be consistent with the boot project we just made. Spring Data GemFire, Spring Data Commons, and some testing things because we're going to run some tests. So that is our dependencies. So we'll just do a run install here. And we've got all our stuff. Okay, so we want to make our POJOs. So we've got customer and order. So let's just quickly jump back here. So coding the model. So our model's basic. We're going to have a customer object with a name, a date of birth, and an ID. So remember, GemFire is key value. So we're using repositories for our CRUD operations today. So we actually have our key as one of the attributes of the object. Order, we could have an embedded product object, but instead we're just going to have a string with the name of the product and the customer ID, in which we're going to do the co-location with, and then the ID for the order. So we're on keys. We're just using strings, but you can actually put any kind of custom class. And the neat thing is it's inexpensive to iterate through keys. So you can have metadata about the objects and iterate through the keys and sort of do some processing without having to hit your larger objects. You do have to remember, though, as you evict and expire things from the cache, the keys actually remain. So something to keep in mind. Now, object models, GemFire can support object graphs. There are advantages, though, to putting like a key or an ID and having a collection of those instead. Just can be more efficient from a memory point of view. GemFire does serialize. So we're using the PDX serializer, which is interesting because it allows GemFire to grab attributes when you're running a query without actually instantiating the whole object. The way it's serialized or stored, it's got the attributes and their value. It also allows it to be cross-language. So .NET or C# can read objects that were PDX serialized from my Java application. There is custom serialization as well. That's kind of out of scope for today. Just some sizing guidelines. You have to remember redundant copies, room for garbage collection, and indexes. So if I have 10 gigs, that doesn't mean I put 10 gigs of objects in. That won't adequately perform. So there's the Maven. So let's create our object model. So we're going to go here. We're going to create a class. So I want to make sure I get the same model that we used, same package we used for the PDX serializer. So we'll call this customer. So we don't have to do anything fancy with this. And just to make it easier, we'll go to GemFire configs, and I'm going to keep this handy because I'm going to reference this. So this customer pojo I'm putting, it's going to go into this region. So this is a server configuration. So Spring Data GemFire gives us this nice @region customer. So that maps this pojo to that GemFire region. So we had, we had name, and our key, string is a key. Now this key, actually, instead of calling it key, call it ID. We're going to make this the ID annotation. So when we start using our repository, it knows what to do for the key. So now we can just do our getters and setters. We can add toString, all kinds of stuff like that, but actually we will add a toString. Don't worry. Okay, so that was customer. Now let's add order. And just in the interest of time, I might just do a quick copy-paste job on this guy so we can get through all the material this time. So we've got our customer ID, our product name, and our quantity. Again, string ID, we've annotated with an ID. But that's it. It's just a regular Java object. So that's it. This will be what everything is going to operate on. So this is how the grid accepts it. There are sort of a number of configurations on the grid side that we can do. We're not going to get too much into them today, but just to show you where they would be. So we can have asynchronous queues. So write this customer data into something like Hadoop asynchronously or a database. You know, all kinds of extensions and expiration and all kinds of things. So as I said, very rich feature set. But for now, this is good. So we have our model. So the next thing that we want to do is, after creating the model, is repositories. So we're going with repositories, and if you read the Spring Data repository documentation, it talks about repositories basically significantly reducing the amount of boilerplate code. And GemFire, the API, does have a fair amount of moving parts. So there's a lot you have to do. So Spring Data GemFire sort of takes that approach and gives you a nice abstraction for doing CRUD operations. Now, GemFire, Spring Data GemFire also provides a GemFire template. This gives you sort of lower level control, so more lower level CRUD operations, calling of functions, query service, but it requires a bit more knowledge of GemFire to use. So the nice things with repositories, as you'll see, is it's very trivial to code. Now, OQL comes into play here, and this is the query language for GemFire. So it's designed to query objects. You can join between regions. You can navigate object collections. You can also invoke methods of objects. So here you can see, that was unexpected. Here you can see P, name, starts with, bow. So name is a string, and we're using this starts with. And you can see there's counts and limits, and you know, it's a fairly rich query language. So what the repository does is you basically define an interface that extends the GemFire repository abstract class, and you register your package that contains it. And Spring Data GemFire under the covers spins up everything against the GemFire API that's required to do the operation. So let's add those to our code base. So we're going to add an interface. We're going to create something called repo as a new package, and we're going to call this customer repo. Sorry, it extends the interface GemFire repository. Oops. There you go. Okay, so it wants to know what key is, so that's the class. So we're dealing with string, and it's the customer repo. So we're taking strings as keys and putting in customer values into the grid. That's it. That's all we have to define to get basic CRUD operations. I can do more advanced things, so I can create, a method that returns, let's say, a list of customers, and I would specify the OQL. So we'll see what that looks like in a second. But for now, let's just get this example working. So we'll do a new interface, also in the repo, and we'll call this order repo, and we'll add that. And again, string order. I make sure the right order. Yes. Okay. So that's all we needed there. So what we're going to do is install this. We don't have any test cases yet, but luckily that's next in our agenda. So let's talk briefly about test cases, and then we'll look at getting this on the grid. So test cases, it's difficult to test like a true distributed system. I do have a number of nodes set up, but it was a bit of a hassle for me to set that up. There are some frameworks. We're not going to cover that in this session. Today, we are going to talk about just creating a single GemFire node within our JUnit to actually test. So we can work directly with the cache factory and get a reference to the cache objects. This is good if we're doing lower level operations, so we can actually do direct manipulation with the regions themselves. So remember, when we're on the client side, so remember, with GemFire, you're coding on the server side or the client side, and you can get a reference for the cache on both sides. If you're on the client side, you're working with the client cache, and your changes get propagated across, and also the grid is pushing things to you. If you're on the server side, you're working with the data on your particular node, or potentially making calls to other nodes. So we're testing that. The approach we're actually going to show is using annotations to basically bootstrap up a little embedded cache, and we're going to configure it to be a cache server and a locator all in one. So let's add that to our little sample. So we're going to go here to test. Now, rather than typing and configuring this, we spent a lot of time previous session. Let's actually just paste this in. Test resources. Whoops. Not what I wanted. Okay. So just grabbing my test cache here. Okay. So let's explore this configuration. Delete that. Okay. So what does this give us? So it's a Spring Data GemFire configured cache, very similar to what we pushed up to the server. It's got properties, and it's basically just configured on its own. So it has a locator, which it's hosting itself. It also has a cache server. So it basically behaves as a locator and a server all in one. You'll see it has a serializer, and I've configured that here. So in our server example, that's configured in the cache.xml because GemFire has that under control. In a pure Spring example, and this is how it'll be, following the next release, I can do everything here. So you'll see I've got my region. what I've added to support the repositories is this. So this lets Spring Data GemFire know to scan this particular package and look for repositories. So those are these interfaces, and then it can do what it needs to do behind the scenes to get you the API code to actually do the operation. So let's do a test. So we'll create a simple test class. So we'll call this data test. And this will be in, where are we? IO pivotal GemFire. So I'm going to do another copy paste just to save a bit of time. So IO pivotal GemFire webinar. Okay. So the first thing we want this to do is we want it to bootstrap up this little test cache that we configured. So we can add these annotations, and that gets us that. So when this class spins up, it's going to bootstrap that little cache that we configured. Now, next thing, we want to auto-wire in the repositories we just created. So we got our customer repo. And we've got our order repo. Okay, and we want to do a test. So let's just make this a little bit easier. I can find where my mouse is. Too many screens. Okay, so our test is simple. Webinar model, W till date. Our test is simple. We create a customer object, populate it. We do customer repo.save, which is going to save into our little sort of internally running grid, which will live for the duration of this test case. And then we're just going to assert that if we do a get on or find one, so remember, we got to look up by key. So that was our ID. So we're doing a find one on a string value equal to that key, and we should get back our customer object. Same thing with order. So let's see how this goes. So in the previous webinar, this test case failed a couple times due to typos. So we'll see if copying and pasting helped its success. Wow, it did. Okay, so both succeeded. So we were able to persist our objects into the GemFire grid and get them back. So that's good. What we want to do now is let's push up the WAR file that contains all of this to the grid. Now, because the grid already has PDX configured, it actually could accept these objects in PDX format from the client and not actually even need our domain model. But there's situations where, on the server side, you may need to cast an object you're getting on the server side from GemFire to its actual type. So it's not a bad idea to push your domain objects up there. Also, these repos come in handy because when you add functions and do execution on the server, it's often nice to have a repo since it gives such a, an easy format. So we can compile this code and push this up to the server. So again, we'll use Ansible for that. All right, so that will push the jar files up, and that should get us going. So let's jump back to the presentation. So we're actually going to, before we talk about functions, we're going to create a client. So the client is actually going to give us an opportunity to, put these repos to good use and actually put some things into the grid and just sort of see another application communicating, with the grid. So we're going to use Spring Boot to start this out. And Spring Boot makes it really nice because it has this application sort of main method. And this gives you a really great place to import a client GemFire configuration. And this is what that looks like. So let's code that up right now. So we'll create a quick Spring Boot application and have it do some operations. So Spring Starter Project, we'll call this GF Client IO. Pivotal GemFire webinar. So we're going to use GemFire. I really like to use Timeleaf, but unfortunately, I don't think we'll really have time in this session to actually build the UI. So we're going to leave out web and Timeleaf. So that's all we'll need for now. But you saw in that demo application I started up with, certainly you can drive really responsive UIs if they're backed by GemFire. Okay, so here's our application. What we need is a client connection. So to do this, we're going to configure a client cache. So for our namespaces, Spring Data GemFire, Utilities, Repositories. So I'm just going to grab, rather than have you guys watch me fill this out, I'm just going to grab one from an existing application and we'll tweak that.
Look, while you're looking that up, just so you realize, much more active audience on this one. Bunch of questions teed up.
Okay. Well, I think I'm doing much better on time this time, so we actually may have a chance to answer these at the end.
And almost everyone's still on the line. There's very few people that have had to leave, so
wow.
Really interested. Clearly, 150 people still very interested.
Excellent. Great. Thank you for hanging in, guys. Okay, so quick copy and paste job here, but let's review what I've done. So this is a client cache. So actually, when I'm working with projects, I like to often put this client cache in with my domain model. So where I have my POJOs, I'll actually, in the class path, throw in this client cache. And that way, everyone will just have it the minute they have the POJO jar. But in this case, we actually configured it in the application itself. So we've set up a serializer. So when this application is writing to GemFire, it'll write serialized objects. We've configured a pool. So you'll see when we're configuring a pool, we can put servers and locators. We're dealing with locators. We have two of them. So if one fails, the pool will automatically go to the next one. And we've configured the port. This is our client cache, references the pool, and uses PDX serialization. We have two client regions, customer and order. So we're basically just picking up the regions that are on the server. We could only have customer if we wanted. We don't have to pick up everything that's on the server. Now, one thing I haven't done that we will see later is I can actually enable subscriptions. So if I set subscription able to true, when this client connects, GemFire will note it has subscriptions. So certain regions, I can specify the behavior. So I can add an interest. I can essentially say if any client hitting the grid changes this region, broadcast out my changes. So GemFire will push all the objects in the region on the grid side out to all the clients that have subscribed. Now you're going to get a ton of objects. So I can set expiration and all sorts of policies here to keep my little local heap from getting overwhelmed. Or I can add a continuous query. So continuous query is I add a subscription, but rather than saying give me everything in the region, I say only give me the objects that match a certain criteria, and we'll see an example of that. But it's a very powerful feature of GemFire, this ability for it to sort of push information out to the client. And of course, I'm going to be using repositories, so I've registered. I put that in there. Okay, now we don't have time to build a fancy UI, but we will when we review some code, look at some. So just to make things fast, we're going to add a class called cache loader. Just throw that in there. Going to make this component. So this is a little trick my buddy Josh Long taught me for quickly loading up a grid. Just going to grab code here. The time it took me, I could have typed it almost. Okay, so what do we got? So we're auto wiring in, that's not the order object. Oh, we have to add that to our class path. So let's add GF server side. That's better. Okay, value till date. Great. Okay, so we just ripped off what was in our test case. We've got a method called load data. We auto wire in our two repositories, almost identical to our test class. Now, the nice thing is Spring Boot gives us this little hook we can have here. So I can create a command line runner with a run method. And it'll say loading the grid, and then it'll call CL load data, which will auto wire in our repositories and then do some CRUD operations. So remember, what happens is we have a client cache. We have copies of those regions. So the changes happen first on our local regions, and then the client cache, using this pool, sends the changes over. Now, when we connected, we said we are interested in customer and order. The grid already knows how customer and order will be distributed. So our lowest level of specificity is something called bucket. So my client already has a metadata map of where everything is. So when I call out to the system, when I first connected, I hit the locators. But after that first connection, I actually have the IPs of all these servers. So when I'm actually doing the put, I'm actually doing it directly to the cache server that has the primary copy. And if anything happens to that server, a new server gets the primary copy, and my metadata is updated. So it's very adaptable. Okay, so this should be good. Let's take a look and see. Let's make sure the grid is okay. So we pushed everything out. Can't remember if I restarted the cache servers or not. So we're just going to stop them and restart them. Now, you can do a rolling restart, but when you're changing things like cache definitions or domain, actually, you could do a rolling restart with the domain objects. PDX is backwards compatible, so you can have the concept of object versioning. It won't break it. I didn't go to the trouble of configuring this to do a rolling restart, so I'm just doing kind of a hard restart. Obviously, if this is a grid providing a high level of service, I would put more thought into this. But just for the purpose of this demonstration, I'm just going to do a quick rebounce. And let's start it up. And so we've pushed up our jar file. We've got all our configs on there. So essentially everything we need is on there. We just got to wait for our members to come back up, and then we should be able to spin up our little demo application and see a couple of objects hit the grid. And once we've done that, we're going to briefly, and I mean extremely briefly, look at a function, just look at the code, and just briefly touch on Spring XD, and then we'll close it down. See, Peter, I'm only going to be about 10 minutes over this time instead of 40. Okay.
No worries.
Back up. Thank you very much. Okay, so we'll run this as a Spring Boot application. Now we'll see. Okay, no qualifying beam for customer repo. That's a typo or something in there. IO pivotal. Repo customer. IO, by copy and paste, may have gotten here. IO, GemFire. Okay, seems like it should be okay. Oh. You know it's live now. Oh, yes. Did I not wire that in? Ah, of course. I forgot to wire in the client config. Kind of a critical thing. So we're trying to use GemFire, and there actually is no client connection. So that's not good. So we'll add this client cache. Okay, this will make a world of difference. We'll import that. Okay. All right, so let's run this as a Spring Boot app. Okay, no red, all black. That's much better. So let's just take a look what happened, and then we'll look on the grid. So my client cache started up, and it created regions on the client side called customer and order. And in that, it got all the relevant metadata. You also see some PDX operations going on. So it serialized my objects into PDX format and then sent them across to the grid. So let's take a look at the grid, and we go to data. And sure enough, we have a count in each one. We have a browser where we can look at stuff. So we can just put OQL in here, select star from customer, and we'll execute that. Got that. So there's our customer. Just to make it interesting, we'll just quickly put another one in. So we'll run it again with a different key, 2 and 2.
So while you're there, actually, there was someone that had a question about why do you include the ID of the object, which is also being used as the key on the as on of the object attributes. I think there's some bad English there, but
right here.
Yeah. His question was, what was the thought behind including the ID of the object also being used as the key?
Right. That's just how the repositories work. So the repositories are just a really nice convenience class. So you'll notice my repository, customer repository, I didn't really define anything. But if I get the reference to my customer repo, you'll see there's all sorts of operations. And one of them is save, but save only takes the entity. So how it knows how to put the key to do the actual put is with this annotated attribute. So if we look at customer, that's annotated. So this is just for me to work with the repositories, essentially. You don't have to do it this way. You definitely don't have to do it this way. Like you could do a more, typical put with the key and the value. This is just sort of one programming model, which is, a fast one.
Cool. Sorry, I thought I'd sneak that in there just because you were right on it and the guide asked. So. Yeah,
no problem. Hopefully that answered the question. So we've got a really basic application going, and we've got our two entries. So we'll wrap up quickly here because we're a little over. So the last sort of topics are functions. Where are we? Spring XD is coming, client, function. So functions allow me to embed logic in the grid, and from a client, I can say execute this function, and the function will actually execute and return results. So if I have 6 members, I would get back 6 result sets in my little client, and I can even create my own result aggregator. So this allows me to, I could have terabytes of data spread across and do a huge computation in memory. So it's Pojo-based. What we're going to do is I wish I could, but we don't have time, unfortunately, to code one up. So we'll look at an existing one and just sort of see how that works and how you wire it in. Just take a second for my IDE to switch workspaces. Okay. So this is that sort of initial demo you saw with, the shoes and the sort of flashy charts. We have a function here. So this function is called order counter. Actually, let's pick one that's less verbose. Product group counter. So this is a function. All I've got is a method that returns a map, in this case, string atomic integer. I've auto-wired in my repository, and this is using the repository to grab data off the grid and do an operation in it. And there's all sorts of configurations. So ideally, GemFire is really smart in how it executes functions. So what's going to happen is if I've got this partitioned nicely, and I've got let's say, an entire large data set spread across all the nodes, each node will have its own little collection of data. And when I call this function, they'll all execute in parallel and, do this calculation on their, 25%, let's say, of the entire data set. And then the aggregated result gets returned back to me. So Spring Data GemFire makes it really easy to call this. So all you have to do is define an interface. You can specify on region, on server. So this executes on this particular region, but there's all kinds of different scope for functions, which we don't have time today. But I've got this idea called count transactions, and it's going to count transactions. It takes a customer object and it returns a list of integers. Why a list? Because I'm getting back a result from each node in the grid. Now, I could, add a result collector, but in this case, in the application that's making use of this, it does something with that list. So this gets pushed out to the server, and then a client can actually call this function and have the server kick off this logic and have it run in parallel and get that result back. So it allows a really lightweight client with a really simple programming model. Let's see in a test case how you would call it. Here's our function test. So this setup just puts a bunch of objects into our little embedded grid. Here I am calling the object. So this is it. I'm just doing this product group caller, count by brand. It returns back, a list. I only have one member, so I just get the first one. But my application actually makes use of this list to do a few things. But the nice thing is I could have, a gigabyte of data in the grid and just have that all crunch in memory, and my little lightweight client gets back the results, and then I can do a much smaller aggregation. So that's functions. Unfortunately, we won't be able to dig much deeper into that. So that pretty much wraps up most things I wanted to talk to. One honorable mention is Spring XD. Spring XD has done a really good job of integrating with GemFire. So if you haven't looked at Spring XD, I recommend it. It's a really interesting project. It's sort of a blend of integration, batch, and Spring Data. It has the ability basically to take data, transform it, so you have sources and sinks. So GemFire XD comes built in with a couple of GemFire sources. So one called GemFire Source, which implements a cache listener. So it basically has that subscription, and you specify a region, and as data gets put into the region, it gets picked up by the gem-XD or Spring XD source. Also a continuous query, so rather than getting everything from the region, I just get specific things, and that gets pumped into my Spring XD stream, and then I can transform it, put it somewhere else. It also has support for sync, so you can get data through Spring XD from another source and dump it into a GemFire region. It does write directly to cache servers, so there is, a bit of configuration there, but, nothing too serious. So this is, Spring is really good at simplifying things, but also tying things together. And, between Spring Data GemFire and Spring XD, GemFire becomes a much more accessible product. So we only scratched the surface. I mean, Spring Data GemFire gives a really nice integration with Spring Transactions, so you can have transactional support with your GemFire-backed applications. We didn't even get a chance to look at read-throughs and write-throughs. Client notifications we sort of touched on, but, there's a lot more there. But hopefully I did pique your interest and that you might want to take a look at this. Here's the further reading. So GemFire documentation, Spring Data GemFire docs, and the Spring XD docs. So that is it for today. Peter?
Why don't you leave this slide of follow-up links up while we do the Q&A real quick.
You got it.
So thank you very much, Luke. So allow me to just guide you a little bit and on length of answers too, because there's a bunch of questions. So one quick yes/no question: were you just demoing GemFire 8?
Yes, I was.
Okay, awesome. Just curious that someone asked that specifically.
Well, I know why they asked it, because Pulse probably didn't have that data browser inside of the UI. So the GemFire 7 version of Pulse didn't have a data browser built in. So someone might have been impressed to see that, because it is a really nice addition.
Ironically, just not 3 seconds ago, Maziar was saying, hey, it's cool how data browsers now available as part of Pulse through a web-based interface. Yeah. Did a project GemFire 6. So and I was commenting on that earlier as well, that Pulse UI is pretty slick. Yeah, nice. Okay, cool. So let's see, a bunch of other questions. The most popular question of today's audience is, can you compare and contrast why and where you would use GemFire versus something like Redis?
So Redis is a great cache. It's very fast. If I was to put a GemFire cache, in a tractor pull against a Redis cache, I would actually put my money on the Redis cache. Where GemFire shines is it's actually a true cluster. So I can, expand out the grid, and as you guys saw, as members are being added or subtracting, the data is rebalancing. It has redundant copies. It ensures consistency. It's got the WAN gateway, so I can have a grid in New York and another grid in Tokyo, and they'll update each other over the WAN. And, as my markets close in Tokyo and open in New York, I've got the data already there. So it's just a much more robust, it's a grid as opposed to a cache GemFire. That would be my answer to that. And I'm by no means an expert in Redis.
That's well said. I think, I think and Redis is mostly, I think Redis is a little bit more of a disk-based as opposed to an in-memory, if I recall correctly. I could be wrong on that, actually.
I think, you know what, I don't know too much about Redis.
Yeah, I shouldn't say that. I'm not quite sure. Okay, cool. Any other thoughts on the GemFire versus Redis thing, or shall I move on?
Well, I could go on and on, but let's move on. If a burning thought comes, I'll come back to it.
Okay, cool. Yeah, just because like 2 or 3 people asked. So, one person, Anil asks, is the configuration that you were creating in Spring Tool Suite being copied to the GemFire servers, both the locator and the server?
That's right. So what I just did with Ansible is, well, actually, no, that's not right. So I'll pull up Ansible. So when I copy, this is me copying, well, that's me starting a server. Here's me copying a star to the server. And, oh, I actually copied that to the whole cluster. Okay, so yes, it was copied to the servers and the locators, but that was accidental. What I meant to do, and as you can see, it didn't really matter. But with Ansible, what I did, as we wait for this cursor to slowly make its way, what I meant to say is servers. So really, the configurations only need to go to the server. So when I use gfish to start a server process, it takes the properties files, it takes the cache.xml. That cache.xml that starts up, is bootstrapping objects, and those need a class path. So really, it's only, I was using Ansible to push that stuff out only to the server processes. But the way I set my grid up, there's no real changes to the actual servers themselves. Even the class path, I'm not making changes to that. I'm running a setEnv script to sort of set up my environment right before the gfish script runs. I just sourced that. So any server could be a locator or a server. So it doesn't really matter, I guess the answer is. But in this case, I was pushing the configs just to the ones that were running server processes.
Got it. Okay. Let's see. Question about how does let's see. Sorry, hold on. This guy, he broke his question into a couple pieces. 1 second. Oh yeah, right. Okay, so this is about sort of write-through aspect, which we obviously didn't get to cover today, but Matthew asks if his app uses GemFire, writes to GemFire, can you pass through to other storage systems out the back, right, such as Hadoop or perhaps a SQL database?
So let's look at that. I'll just quickly pull up a configuration that demonstrates that.
And he was hoping that it was configuration-based and not hard-coded as well. So,
it is configuration-based, yes. Your hopes are correct. Let's see. Where did I configure that? Oh. Let's see. Sorry, it'll just take me a second here. So the shoe example I showed you does do a write-through. And the write-through is configured like this. So I have a partition region called alert. It has one redundant copy, and it has an asynchronous event queue. The asynchronous event queue can run in parallel or serial. It has a batch time interval, so every 10,000 milliseconds, it writes the objects that are there. But you actually have a very robust, you can do a batch size, lots of options here. And then I have this async alert writer. The async alert writer is just a simple Spring template, Spring database template. And that just, writes, I'll show you. It just writes POJOs to the MySQL database. So it's fairly easy to configure. You just put it inside of the region, and then I coded everything with Spring. So GemFire gives you the configuration point to say there's going to be a write-through, and you sort of have control to how many threads do the write-through, how large those threads get before writing, or how frequently they write, and then it's up to you to code. So I've done write-throughs to Hadoop and serialize things with Avro. I've done write-throughs to databases, write-throughs to just straight file systems. So it's very flexible. It's one of my favorite features.
Cool. That seems like an ideal use case for hooking XD up, if I may be so bold. But anyway, and maybe take some sort of the actual code writing out of that. But all right, cool. Let's see, just a couple more questions. We're almost there. Matthew, I know you had another question, but I just gotta give some love to some of the other folks. Let's see. Gosh, sorry, I got lost in the stack here. Where was it? Oh yeah, he was curious about integrating GemFire with BI tools, and I was tempted to say GemFire XD, but I wanted to head check that with you.
Well, GemFire XD is GemFire with a JDBC front end, so it's not key value. So you don't use a cache API anymore. You're using JDBC. So it would hook up with most BI tools. I used to work previously for JasperSoft. Jasper Reports has a very extensible reporting API. It can report off objects. So with something like Jasper Reports, you could actually report off a GemFire. But yeah, when it comes to GemFire, now one interesting thing, and I didn't really get to show it, GemFire 8 now has a REST endpoint. So you can actually designate cache servers to be REST servers, and you can make REST calls and actually get back JSON representations of the objects. So that allows, let's say, Python users to just using HTTP make use of a GemFire grid. So not really related to BI, but that just tripped my memory.
Another integration point, yeah.
Another integration point, yeah. But in terms of tools, GemFire, since it's an object store, it's a little trickier to report off of. You need sort of the lower level reporting libraries. GemFire XD, which we didn't discuss today, being that JDBC front end, it has more BI capability.
Got it. Understood. Okay, I think we're pretty much there. And then I just to clarify, if someone's working with GemFire, is GemFire XD just kind of seamless layover on top of that? Is it or is it a totally separate thing?
Well, it's pretty different. Like, you would have to, before embarking forward, you need to decide if you want to do key value store versus a SQL store.
Okay. So you do need to decide up front. That's what I wanted to get at. Thank you.
Yeah, you do, unfortunately.
Okay, that's cool. No worries. I just wanted to make that clear. All right, cool. Yep. And then almost there. Last question. Oh my gosh. What's the last question? Oh, no, we got a couple more coming in. Let's see, is it possible to persist all these objects on a Hadoop cluster? How would the integration be done, node by node, something else? I think we kind of addressed that a little bit, but frankly, I would vote for using Spring XD. But anyway,
Spring XD is a great way to put things into Hadoop, for sure. Spring XD uses Spring Hadoop, which wraps things like Kite SDK, which has great libraries for serializing to HDFS. When I did do a GemFire to Hadoop integration, I just actually looked at how Spring XD was writing it and just did the same thing. So I just used the same libraries. So yeah, Spring XD is a great way, but totally possible with GemFire. Just using Spring Hadoop, basically. Like the same extension point of the asynchronous writer. So here is the actual code that is doing an asynchronous write behind to a behind the scenes data source. So this configuration here determines how many objects gets batched up and how frequently this code runs. So when one of these threads runs, it actually runs this, which has a list of events. So I can actually deserialize the object and get what the actual object is. And then in this case, I was doing, an insert using a DAO, which is just, with a simple Spring SQL, JDBC template. But you could use Spring Hadoop in this case. And, at this point, right into the HDFS file system as well. But like Peter said, Spring XD has all that out of the box, so it might be worth looking at for that use case.
Perfect. Let's see, two questions that are both performance related. Did you test this grid configuration against what volume of data? The other guy asks for performance metrics for rates of writes. and concurrent CQ clients is the max. I think CQ must mean continuous query.
Yeah, continuous query, yeah. Excuse me. I just got this configuration set up for this webinar, actually. I got it running yesterday, so I haven't really kicked the tires really seriously on any of this. So, I mean, all those sort of benchmarks really depend, you know, the GemFire has a ton of configuration, which, you know, can be a little daunting at first, but once you get it tuned, you know, it's rock solid. So a lot of it depends on your network and how things are configured. It's very network bound because it's using the network for its membership communication as well as its communication between client and server. So it's hard to estimate those. Like that Forbes article does give you, you know, a heads up on, you know, some bigger companies that have really invested in their gem installs. You know, like, well, I forget, the Chinese railway was, you know, like a huge amount of transactions per second. I forget the exact amount, but one of them had, you know, 4,000 concurrent users. In terms of continuous query, you know, I don't have any numbers off the top of my head, unfortunately.
But proof point that we've been seeing is that, you know, a lot of the uptake for this kind of stuff really is in financial services and in other types of systems where, you know, milliseconds and even sub-milliseconds sometimes matter, and you know, they're you know, that's where this does start to shine. So that, you know, just to have some confidence that that's what it's built for, even though we're not able to quote the specific numbers, and there's plenty of customers to back that up. Exactly.
I mean, this product cut its teeth in Wall Street about a decade ago doing, you know, risk calculations. So as Peter said, you know, milliseconds really matter. And obviously the cases we looked at today were not that performance intensive. Today's goal was just sort of to show you how to code against it and how it can scale up and down and take care of a lot of your scalability concerns for you.
Awesome. I think we made it through. Oh, sorry, last one. Nick Koblov asks, recommended recovery procedure in case of GemFire file store corruption.
That's a great question. I would have to know more about your configuration. I think you should get Nick's email and put him in touch with me, because he sounds actually like an existing GemFire customer, and it'd probably be good to reach out with him. But I mean, there's a couple things you can do. We didn't really cover file storage in this particular session, but Nick, that's something I would definitely like to communicate with you, you know, directly.
I am posting your mail to him as we speak.
Excellent.
Okay, cool. All right, there you go. All right, so I think let's wrap it up here. We'll be posting a recording of this webinar to spring.io/video and spring.io/blog within the next 2 weeks. And those are always, you know, there's slides as well as the video included. So if you want to get a notification of when the replay is available, just subscribe to the Atom feed on the blog is probably the best thing to do, because then you'll get all the great blog content from our engineers as well. All the Spring 1, 2GX replays, all that good stuff that comes out of the blog. If for some reason you just want the videos, you could do spring.io/video and just subscribe to the YouTube channel. And then if this topic interests you, I would highly encourage you to join us again on January 27th, as Gary Russell, the lead for Spring Integration, is going to introduce the Java DSL for Spring Integration, which is a fairly new feature that started the introduction around the Spring Integration 4.0 code line. So join us for that on January 27th. The registration is on the website if you go back and look on the blog. And I just want to say thank you so much, Luke. This is it's a tough topic. It's you know, how to set up globally distributed fault-tolerant object caches that you can access from a variety of clients, and you know, I mean, it's just there's a lot of there's a lot of tweaking and a lot of stuff that can be done to accomplish particular client scenarios. So it can appear to be overwhelming from a configuration standpoint, but really appreciate you joining us to kind of show us, hey, how do I get started with this thing as a developer, right?
Yeah.
How do I hack this thing as a Java developer, and most importantly, a Spring developer? Yeah.
Spring helps a lot. That's true.
Yep. Excellent. Well, you helped a lot, so really appreciate that. And
Thank you.
There's still 77 folks on the line listening to us from 150. Fantastic. So you had a lot of folks interested in the question in the Q&A as well. A lot of people saying thank you right now for your efforts. So
thank you, everyone. I really, really appreciate it.
Well done, and I hope you feel better soon. Thanks for doing this even while you were sick.
No problem.
Have a great day, everyone. Take care.
Okay, bye-bye.